Greetings everyone, today we will learn third chapter vectors. This would be the first lecture of this series. Third chapter vectors, lecture number first. So in this lecture students, we will discuss introduction to vectors and general points regarding vectors. That what are vectors and theory of vectors, that how vectors are dealt with in nature. So general points regarding vectors, vectors notation, that how a vector is given notation. It is denoted by A, B, C, etc. And magnitude, it is not like that you cannot take any other letter. So you can use anything you like, small a, small. And magnitude of a vector A is given by modulus of A. Right students? Second, representation of vector. Right, how a vector is represented. Representation of vector. Vector A is denoted by an arrow overhead. Okay. Or simply I would write an arrow over a quantity, then it will denote what? A vector. Sorry students. Here this is tail, this is head of vector, and this whole thing, the length is magnitude. I would write length L is equal to magnitude. Okay. Tail is what students? Yes, starting point of vector. Always starting point of vector of a vector. Second, head is what students? Sir, not the starting point but the ending point. Yes, very nice students. Ending point of a vector. So I will just repeat myself. And what is length? Magnitude of a vector. Length is magnitude of a vector. Right students? So this is the basic thing. Now moving forward to another question. So fast question has come. Question regarding a theory has come, students. Regarding theory. Can a vector be represented by a single letter, not multiple letters? So the answer to this question is a vector can be denoted by two letters. Suppose AB. This is a vector given. So what the meaning of this vector is? A is the starting point of vector AB And B is what, students? Yes, ending point. Very nice, students. Ending point of vector AB. Okay. Now parallel transportation. What is parallel transportation? Parallel transportation of vector. Parallel transportation of a vector. Sorry students, I am having little bit cough. Parallel transportation. Parallel transportation of a vector. So what parallel transportation of a vector means? So you have a vector A in a coordinate system, right? This is x-axis, yes, and this is y-axis, right student? This is the vector A, okay, and this is making 60° with the x-axis. Now what I will do, I will parallelly transport it. So parallel transportation means that the coordinate system remains the same, or generally the angle remains the same with all the axis system, and the vector moves parallelly here and there. So like I am taking, it is 10 meter away from this x-axis to a new axis system x dash. Okay students, and this is what? This is y-axis, and this remains what? Again A vector, and here it is making 60°. So the magnitude is same, magnitude length is same, and direction is same. So what is this? What happens here? The vector is parallelly transported. We say that the vector is parallelly transported. Okay. What's the use of this? We use this to actually get the resultant of a vector, of two vectors. So we will see it later. Let me deal with the theory for now. A vector can be displaced from one position to another, from one position to another position, to another so during this displacement, during the displacement, see here, vector A is displaced 10 meter away from this coordinate system to this coordinate system. During the displacement, if we do not change magnitude, if we do not change magnitude and direction, magnitude and what is, students? Direction and direction. So direction is important. Yes, students, direction is very important. If direction is changed, then the resultant will not remain the same. Then vector remains unchanged. Right, students? Next part, angle between two vectors. Angle between two vectors. Angle between two vectors. That how we get the angle between two vectors. So certainly, when if you see a diagram and you see that the vector is making two vectors are making angle with each other, it does not mean that always the angle between them is their angle. Let me show you with example. Here, this is what? Two vectors. This is vector B and this is A. This is 120 degree. Now notice that the angle between them is 120 degree. Now what should I do? But this angle cannot be the resultant of the whole A and B. Why? Because I can parallelly transport this vector to here, making an angle of 60 degree between them. Let me show you how. So this direction remains the same and I am parallelly transporting it to here. So A remains to be here and this goes here, B vector, okay, with the same magnitude. So the angle becomes 60 between them, okay. Okay, students. So angle between the two vectors is 60 degree, not 120 degree. This is A, this is B. Right, students? So this is the thing. So notice one thing, the two vectors have the same tail origin and they are moving in other direction to each other. Two vectors are drawn from one point to in such a manner, from one point in such a manner that arrows of both vectors of both vectors are what, students? Are outwards towards each other, right, students? Or outwards towards each other, right, students? Or outwards towards. So what you are writing outwards towards? Outward from that point. Yes, what I wanted to say, outwards from that point. From that point. Yes, this is the right thing. From that point. Now, the smaller angle will be the angle between the two vectors. Now, the smaller angle will be the angle between the two vectors. Will be the angle between two vectors. Right, students? Definitely, sir. This is what happened there. Yes, certainly. This is what happened. B and A were two vectors. 120 was the real angle between them, but we notice that the angles that's supposed to be made between them should be 60 degree after parallel transporting. So this. So what should I write theta as? Angle between two vectors? Yes, 60 degree. Hence, angle between A and B 60 degree. Right, students? Yes, sir. This is the thing. Note. Theta can be 0 degree to 180 degree. Okay, but not more than 180 degree and never less than, of course, 0 degree. Types of vectors. If this angle is going more than 180 degree, what do you do? Yes, you are supposed to take the reverse of it. Types of vectors. Types of vectors. First, unit vector. Unit vector. A vector of unit magnitude is unit vector and gives is unit vector and gives direction. So basically the work of unit vector is to give direction. Unit vector is unit vector and gives direction of vector. Direction. And gives direction of the vector A. So what should I write, students? A vector. for unit vector, I would write a cap. Right, students? It is denoted by this symbol, and it meaning a cap or a cap meaning thus a cap is generally a vector upon the modulus of the vector A. Okay, students. Now, it gives it represents in the coordinate system. How it is represented? It represents, so it is represented by I and j. Yes, but along what direction? This represents directions x, y, and z. Directions as I, j, and k, or x cap, y cap, and yes, what should I write? Z cap, z cap, respectively. Right, students? Certainly right, sir. Note cap is unit, zero vector or null vector. Okay, so zero vector and null vector. You would be thinking that zero vector is a zero vector. What is the use of it? Quite interesting. Everything in mathematics has certain use if it is mathematical. Okay, students. Zero vector or null vector. A vector of zero magnitude is null vector or zero vector. You would be saying, sir, why we are studying this zero vector? Let me tell you why. First point, null vector in itself has no direction. Null vector being a vector, but it does not give direction. Null vector has no specific direction. Means it is there to represent a quantity. The position vector of origin is a zero vector. Okay. So everything being a position vector of origin of origin is a zero vector. Third, null vectors are of mathematical importance. Not physical, are of mathematical importance. So in physics, even they are represented, but they are only for representation in mathematical form. Now the next part, which is equal vectors. Equal vectors both vectors should have same magnitude, and what is students? Same magnitude and same direction. Then they are what? Equal vectors, same magnitude and direction. This was easy, sir. Yes, certainly. So they can be a reference of different coordinate system, but direction and magnitude should remain the same. Next part, so many kind of vectors. Yes, students, many kind. Parallel vectors. What are parallel vectors? So vectors that are parallel. Yes. Both vectors have same direction. Same direction means they are parallel, not inclined to each other by 1 centimeter or anything like that. Antiparallel vectors so that are antiparallel. Yes, that is also true. Antiparallel vectors. So antiparallel means both vectors are in opposite direction. Right, students? Certainly, sir. Next part, negative vector. So negative vector is easy. You put a minus sign. Yes, student, but here's a property that I want to show you or relate you with, that can be of much use in your future classes. Even here, but when you will actually move higher and higher. Negative vectors. A vector of equal magnitude but acts in opposite direction. A vector of equal magnitude but acts in what direction? In opposite direction. Yes, very good, students. And then can I say, students, this? Can I say A is such that it equals to minus B? Yes, students. This implies A plus B should be equal to 0, right? So this is the meaning of the whole thing. Remember this thing, that this is actually two vectors that are opposite to each other, concurrent vectors. So concurrent vectors, actually word is very difficult, but it is not so difficult in understanding. You would say, sir, there is nothing difficult once understood. So concurrent vectors, concurrent vectors, concurrent vectors, vectors having same initial points, having same initial points, yes, having same initial points, having same initial points. So can you explain yourself? Example, we'll give you an example to explain myself. This is vector A, this is B, this is C. Now you have understood what I mean. This all what are? This is concurrent vectors at O. Next, coplanar vectors. Coplanar vectors. Vectors lying on same plane. So not always vectors has to be lie on the same plane, but if two vectors are lying on the same plane, they are coplanar. Vectors lying in same plane. Suppose x, y, x, z, like that, in same plane. Sorry students. So suppose xy plane, A and B are there. A and B are there on xy plane, but on xz plane we have C vector. Okay, then A and B are coplanar but not C. Are coplanar but not C. Okay students, so the next part, now what? Orthogonal vectors. Orthogonal vectors. Two vectors have 90-degree angle between them. Have 90-degree angle between them. Right students? Between them. This is the thing. Next part, multiplication and division of factors. Multiplication and division of factors, and division of vectors, and division of vectors. By what? By scalars. By scalars. Not to make your life very tough. By scalars. The product of vectors product of a vector and a scalar the product of a vector A and a scalar M is a vector. Quite interesting, no? Is a vector ME. Okay, this is basic thing. So what would I write? You think of yourself, what would be my next step? Some multiplication of a vector with a quantity? No, students, no, certainly not. This is very basic. It is about the representation. ME is such that if the modulus are such that, then it gives ME, and modulus meaning is what? It removes the positivity and negativity. The quantity becomes whole positive. Also, M plus N A, then what is, students? MA plus NA. So it is for the magnitude of a vector. Also M N A, my speed, MA should be what? No, this is actually a wrong statement. NA, yes, this is right. A vector is such that it is multiplied n times A and then again multiplied with a scalar. And I would write M and A. Okay, students. Division of vector. Division of vector. Division of vector means 1 by MA. Okay, students, where M is a non-zero value. Right, student? Scalar quantity or anything. Scalar. Okay. So our lecture ends here. Thank you.